Hello everyone, welcome back to Maths Marathon classes. This time I'll be revising all the formulas and concepts of the topic called limits for various competitive exams. Even for board exams, it is helpful to some extent. Okay, so we'll work out formulas on this. Okay, mainly formulas and concepts of this limits topic. First of all, introduction. You must know about the limit. When does it exist? Okay, introduction part of limits. And we'll see what are the various indeterminate forms, algebra of limits, and limits using direct substitution, factorization method, rationalization method. Okay, then we got trigonometric limits, exponential and logarithmic limits, 1 to the power infinity, sandwich theorem, L'Hopital's rule, Newton-Leibniz formula, Maclaurin series expansions, all those things. Okay, in short, I'll summarize all these things. Introduction to limits is limit x tends to a f of x, limit x tends to a f of x exists, or I can tell is equal to L. Say limit x tends to f of x equal to L means that as x approaches to a, means that as x is approaching a, f of x is approaching L. Okay, x is approaching a, f of x is approaching L, then we write like this: limit x tends to a, f of x equal to L. What is left hand limit? Left hand limit is given by limit x tends to a minus f of x. X is approaching a from the left side. Limit x tends to a minus f of x. It's called as left hand limit. X is approaching a from the left side. That means the value of x is approaching a from the left side. Means value of x is slightly less than a. X tends to 2 minus means the value of x may be 1.999, such a value. Okay. Right hand limit is limit x tends to a plus. Limit x tends to a plus of the function f of x. Also we can write limit x tends to a minus as limit h tends to 0, put x equal to a minus h. X tends to a minus means the value of x is slightly less than a. 2 minus means slightly less than 2, 1.999, such a value. 2 plus means slightly greater than 2, 2.00001, such a value. So x tends to a minus means h tends to 0, put x as a minus h. A minus h. A is some positive number there. So 2 minus means 2 minus a small positive number. Okay. So limit h tends to 0 for this case. For right hand limit, x tends to a plus means the value of x is slightly greater than a. So put h tends to 0, x is a plus h. A plus h. And limit exists only if left hand limit is equal to right hand limit. Limit x tends to a, f of x exists. Limit x tends to a, f of x exists only if left hand limit becomes equal to right hand limit. Of course, both are finite. Left hand limit is equal to right hand limit, both finite. Okay, so you must know about this. When does limit exist? What is left hand limit and what is right hand limit? Okay, now I'll go to next indeterminate forms. Which are the indeterminate forms? Indeterminate forms. Some of the frequently used indeterminate forms are 0 by 0, 0 by 0, infinity by infinity, infinity minus infinity, 1 to the power infinity, 0 power 0, 0 into infinity, infinity power 0. These are the frequently used 7 indeterminate forms. 0 by 0, infinity by infinity, infinity minus infinity, 1 to the power infinity, 0 power 0, 0 into infinity and infinity power 0. 7 frequently used indeterminate forms. Okay. And we got next about algebra of limits. Algebra of limits. algebra of limits. Suppose limit x tends to a f of x and limit x tends to g of x both exist finitely. Suppose limit x tends to a f of x and limit x tends to a g of x. Both exist finitely. Both exist finitely. Then limit x tends to a f of x plus g of x. Limit of the sum is sum of the limits. Limit x tends to a f of x plus g of x is equal to limit x tends to a f of x plus limit x tends to a g of x. Limit of sum is sum of the limits. Second one we have limit x tends to a f of x minus g of x. Limit of the difference is difference of the limits. Limit x tends to a f of x minus g of x is equal to limit x tends to a f of x minus limit x tends to a g of x. Limit of the product is product of the limits. I'll write in the next page. Limit x tends to a f of x into g of x. Limit of the product is product of the limits. Limit x tends to a f of x into g of x is equal to limit x tends to a f of x into limit x tends to a g of x. Limit of the product is the product of the limits. Limit of the quotient is quotient of the limits. Limit x tends to a f of x divided by g of x. Limit x tends to a f of x divided by g of x is equal to limit x tends to a f of x divided by limit x tends to a g of x. For limit x tends to a g of x not equal to 0. Denominator is not equal to 0. Or f of a not equal to 0 also I can tell. Limit x tends to a lambda into f of x. A lambda is some real number. In that case you can write lambda into limit x tends to a f of x. A lambda is some real number. Limit x tends to a f of x to the power n. F of x to the power n is equal to limit x tends to a f of x whole to the power n. Limit x tends to a f of x whole power n, where n is some natural number. Limit x tends to a nth root of f of x. Limit x tends to a nth root of f of x is equal to nth root of limit x tends to a f of x. Where n is natural number. Limit x tends to a 7th one this is 8th one. Limit x tends to a f of g of x. The composite function is given. Suppose f of g of x is equal to f of limit x tends to a g of x. F should be continuous at g of a, provided f is continuous at g of a. F is continuous at g of a. F is continuous at g of a. So all these things, algebra of limits. Example for this composite function I can give. limit x tends to a log of f of x is log of limit x tends to a f of x. For example, I can write like this. Limit x tends to a log of f of x. Limit x tends to a of log of f of x. This could be written as log of limit x tends to a f of x. Okay. Example is given. So f of x is positive number. Of course, log of negative number is not defined. So in that case, a composite function is given. Even in terms of e power f of x also can apply. Suppose limit x tends to a, e power f of x is given to you. E power f of x. Example is given here. This is e power limit x tends to a of f of x. Limits involving direct substitution, then rationalization, factorization. That is obviously we can identify it. Okay, I won't give much explanation on that here. And one table I'll give you for this, where f and g are the two functions where limit of that f both exist, both does not exist, one exists, one does not exist. Okay, limit x tends to a f of x, limit x tends to a f of x, limit x tends to a g of x. Here I'll write limit x tends to a f of x plus or minus g of x. F of x plus or minus g of x. Here I'll write limit x tends to a f of x into g of x. The product f of x into g of x. Or you can consider f of x by g of x also. Okay. This is first one. Second one. Third one. Okay, limit of f exists, limit of g exists, limit of both f and g exists. In that case, limit of sum or limit of difference, in that case it exists. Both limit x tends to f of x and g of x exist, and the product also exists. And here this exists, one exists, another does not exist. Does not exist. In that case, the sum or difference does not exist. Can be guaranteed of this. Limit of f exists, limit of g does not exist, and limit of sum does not exist, or limit of difference does not exist. Here it may exist. The product may exist. This table is quite important because what we discuss here in limits, it's also applicable in continuity, also in differentiability. Okay, limit x tends to f of x exists, or both does not exist. Okay, yeah, both does not exist. Does not exist. Does not exist. In that case, sum or difference, limit of that may exist. Here also, limit of the product may exist. May exist. So this table is quite important for various competitive exams. Same thing is applicable even for continuity as well as differentiability. Please make a note of this. Next, I'll discuss about the trigonometric limits, then exponential and logarithmic limits. Another standard limit we have in limits is, I'll write it as standard limit. Okay. This is not much useful for competitive exams because we apply L'Hopital's rule instead of applying this limit. That is, we have limit x tends to a, x power n minus a power n divided by x minus a is equal to n into a power n minus 1. This is true for all n belongs to the set of rational numbers. Also, I can write another form of this, where it takes limit x tends to a, limit x tends to a, x power n minus a power n divided by x power m minus a power m. We can divide by x minus a for both numerator and denominator and apply this limit. For numerator, if we divide by x minus a, it takes this form, n into a power n minus 1. And denominator, we divide by x minus a and apply this result. Instead of n, we have m, that is m into a power m minus 1. Okay, this will simplify to n by m. A power minus 1 cancels from numerator denominator. What remains is a power n minus m. Okay, this is the another case of the first one. Okay, more limits we have. Limits of trigonometric function. Trigonometric limits I'll call. Trigonometric limits. Trigonometric limits. Limit x tends to 0, sin x by x equal to 1. X is measured in radians. Limit x tends to 0, sin x divided by x is equal to 1. X is measured in radian. X is measured in radian. Limit x tends to 0, tan x by x equal to 1. X is measured in radian. Tan x by x is equal to 1. X is measured in radian. Limit x tends to 0, sin inverse x by x is 1. Limit x tends to 0, tan inverse x by x is also 1. X tends to 0, sin inverse x divided by x is 1 is also equal to limit x tends to 0, tan inverse x by x. Limit x tends to 0, sin ax by sin bx is a by b. Sin ax by sin bx, same as limit x tends to 0, tan ax by tan bx. Tan ax divided by tan bx, same as limit x tends to 0, sin ax by tan bx. Sin ax divided by tan bx is equal to limit x tends to 0, sin ax by bx. Sin ax divided by bx is also equal to limit x tends to 0, tan ax by bx. Tan ax divided by bx, or is also equal to limit x tends to 0, tan ax by sin bx. Tan ax divided by sin bx, all of them are equal to a by b. All of them are equal to a by b. A and b are non-zero numbers. Of course, b is not equal to 0. Both I'll take, both a and b not equal to 0 I'll take here. Because sometimes a is, both a and b not equal to 0. Better condition. A can be 0, but I'll take both a and b non-zero. That's better. Stronger condition. A and b non-zero numbers. Okay. So quite useful in working out the problems. Many times questions are asked based on this. Next we have limit x tends to a, tan of x minus a by x minus a is 1. Even sin of x minus a by x minus a is 1. Limit x tends to a, sin of x minus a divided by x minus a is equal to 1. Limit x tends to a, tan of x minus a by x minus a is equal to 1. Tan of x minus a divided by x minus a is equal to 1. Limit x tends to 0, 1 minus cos x by x is 0. Limit x tends to 0, 1 minus cos x divided by x is equal to 0. Limit x tends to 0, 1 minus cos x by x square is half. Limit x tends to 0, 1 minus cos x divided by x square is equal to half. Limit x tends to 0, 1 minus cos px by x square is equal to p square by 2. 1 minus cos px by x square is equal to p square divided by 2. Limit x tends to 0. 1 minus cos px by 1 minus cos qx. 1 minus cos px divided by 1 minus cos qx is equal to p square divided by q square. Limit x tends to 0. Cos ax minus cos bx divided by x square is equal to b square minus a square by 2 is equal to b square minus a square divided by 2. Limit x tends to 0. Tan x minus sin x divided by x cube is equal to half. Tan x minus sin x by x cube is equal to 1 by 2. And also you must know that limit as x tends to 0 minus or 0 plus, sin x by x is slightly less than 1. I can tell you that as x tends to 0 minus or 0 plus, in both the cases sin x by x is slightly less than 1. X tends to 0 minus, what happens? Sin x by x is slightly less than 1. Sin x by x is tending to 1 minus. As x tends to 0 plus also, in both the cases sin x by x is slightly less than 1. Sin x by x is a number slightly less than 1. X by sin x is a number slightly greater than 1. Okay, you must know this. As x tends to 0 minus or 0 plus, as x tends to 0 minus, tan x by x is slightly greater than 1. Tan x by x is slightly greater than 1. Even as x tends to 0 plus, as x tends to 0 plus, tan x by x is slightly greater than 1. So I write 1 plus. 1 plus means slightly greater than 1. So I can write, suppose they ask you to find limit x tends to 0 of greatest integer value of sin x by x. Greatest integer value of sin x by x. If they ask like this, I can take the limit inside this. Okay, please note this. As x tends to 0, sin x by x is slightly less than 1. If you take the limit of this inside, is equal to limit x tends to 0 sin x by x. Sin x by x is slightly less than 1, 0.999. Greatest integer value of that is 0. Limit x tends to 0 tan x by x if I give. Limit x tends to 0 of tan x by x. Greatest integer value of tan x divided by x. That is equal to limit x tends to 0 of tan x by x. Tan x by x is slightly greater than 1. So greatest value of 1 point something is 1. Next we have limit x tends to 0 of x by sin x. Limit x tends to 0 of x by sin x. X by sin x is equal to greatest integer value of limit x tends to 0 of x by sin x. Sin x by x is slightly less than 1. X by sin x is slightly greater than 1. So this becomes x by sin x is slightly greater than 1. So it is 1 point something. Integral value of 1 point something is 1. Limit x tends to 0. Limit x tends to 0 of x by tan x. Tan x by x is slightly greater than 1. Tan x by x is slightly greater than 1. Reciprocal of tan x by x by tan x slightly less than 1. So this becomes limit x tends to 0 of x by tan x, which is slightly less than 1. Slightly less than 1 is 0.99. Integral value of 0.99 is 0. So please make a note, where in all these cases square bracket denotes the greatest integer function. The square bracket denotes the greatest integer function. Denotes the greatest integer function. Next we discuss limit at infinity. Limit at infinity. Limit at infinity. As x tends to infinity, 1 by x tends to 0. must know this. X tends to infinity, plus infinity, 1 by x tends to 0. X tends to minus infinity also, 1 by x tends to 0 minus, that is 0 only. X 0 plus I can write. 1 by x tends to 0 plus, slightly greater than 0. X tends to minus infinity, 1 by x will tend to 0 minus, slightly less than 0. Slightly greater than 0. 0 plus is slightly greater than 0. 0 minus is slightly less than 0. And as x tends to infinity, as x tends to infinity, e power x will tend to e power infinity, which is infinity. E power infinity is infinity. As x tends to minus infinity, e power x will tend to e power minus infinity. E power minus infinity is 1 by e power infinity, which is 0. 1 by e power infinity, which is equal to 0. Okay. So limit at infinity we can discuss. And another important result here is limit n tends to infinity result. Limit n tends to infinity of a power n. Limit n tends to infinity of a power n is equal to 0 if a lies between 0 and 1. If a lies between 0 and 1. If a number lies between 0 and 1, to the power infinity is equal to 0. And if a is greater than 1, if a is greater than 1, it becomes infinity. Okay, two cases I can write. N tends to infinity, a power n becomes 0 if that number a lies between 0 and 1. Okay, for example, limit n tends to infinity, limit n tends to infinity of 5 power n will be equal to infinity. As n tends to infinity, 5 power n tends to infinity. Limit n tends to infinity of 0.2 to the power n is going to be equal to 0. This number lies between 0 and 1. A number between 0 and 1 to the power infinity is 0. If a number is greater than 1 to the power infinity is infinity. Please make a note of this. And also sum to infinity of geometric series is a by 1 minus r. That is also quite useful. Sometimes you may require in limits also. Sum to infinity of GP. Sum to infinity of geometric series. Sum to infinity of geometric series. S infinity is equal to a by 1 minus r. A by 1 minus r if the common ratio lies between minus 1 and plus 1. That is, r belongs to the open interval. R belongs to the open interval minus 1 comma plus 1. Sometimes may come across in limits also these formulas. And also sum to n terms of some special series, I'll call sum to n terms of the special series. These formulas you may come across in limits also. That's why I'm giving this. The first one is sum of the first year natural numbers. 1 plus 2 plus 3 etc. n, which is summation of n, which is equal to n into n plus 1 divided by 2. Summation of n into n plus 1 divided by 2. Sum of the squares, 1 square plus 2 square plus 3 square etc. n square, which is equal to summation of n square is equal to n into n plus 1 into 2n plus 1 divided by 6. 1 cube plus 2 cube plus 3 cube. 1 cube plus 2 cube plus 3 cube. Sum of the cubes, which is summation of n cube I can write. Just n square into n plus 1 the whole square divided by 4. Or I can write this as n into n plus 1 divided by 2 the whole square. Fourth one, I can give 1 power 4 plus 2 power 4 plus 3 power 4 etc. n power 4, which is summation of n power 4, which is n into n plus 1 into 2n plus 1 into 3n square plus 3n minus 1 divided by 30. Divided by 30. Sum of the first n odd natural numbers is n square. Sum of the first n odd natural numbers. Summation of 2n minus 1 is equal to n square. Summation of the first n odd natural numbers. Sum of the first n odd natural numbers is n square. Sum of the first n even natural numbers. 2 plus 4 plus 6 etc. 2n, which is summation of 2n is equal to n into n plus 1. 2 times summation of n. 2 times summation of n is n into n plus 1 by 2. 2 cancels, n into n plus 1. Also I can write sum of the squares of the first n odd natural numbers. 1 square plus 3 square plus 5 square etc. 2n minus 1 the whole square is given by summation of 2n minus 1 the whole square is equal to n into 4n square minus 1 divided by 3. N into 4n square minus 1 divided by 3. All these formulas are quite useful. Next, I'll give a result here where numerator and denominator are polynomial functions as limit n tends to infinity or x tends to infinity is given here. X tends to infinity. Numerator is polynomial a0 into x power n plus a1 into x power n minus 1 plus a2 into x power n minus 2. Like this it goes on. An numerator is polynomial of degree n and denominator is a polynomial of degree m. b0 into x power m plus b1 into x power m minus 1 plus b2 into x power m minus 2. Like this it goes on. There are 4 cases here. The first case is a0 by b0, ratio of the leading coefficient bitten. If degree of numerator is same as degree of denominator. If n is equal to m. If numerator and denominator have same degree, polynomials of same degree, then the ratio of the leading coefficient is a limiting value as x tends to infinity. Okay. Second case is 0 if degree of numerator is less than degree of denominator. Infinity if degree of numerator is greater than degree of denominator and the product of the leading coefficient is positive. a0 into b0 is positive. a0 into b0 is positive. Minus infinity if the degree of numerator is greater than degree of denominator and the product of the leading coefficients is negative. Leading coefficient means the coefficient of the highest power of x is called as leading coefficient. So leading coefficient in the numerator is a0. Denominator leading coefficient is b0. So a0 into b0 should be less than 0. a0 into b0 is less than 0. So all these things you must know. Okay, I can give some examples connected to this also, linking this with the summation formula which I gave here. Okay, these formulas, there are results based on this. Okay, so results connected to this I can write in the next page. Some of the results. Limit n tends to infinity. Limit n tends to infinity. 1 plus 2 plus 3 plus etc. n divided by n square is going to be equal to, numerator is summation of n into n plus 1 by 2 by n square. You'll get ratio of the leading coefficient as half. Limit n tends to infinity. Limit n tends to infinity. 1 square plus 2 square plus 3 square etc. n square divided by n cube. Numerator is summation of n square, n into n plus 1 2n plus 1 by 6 by n cube. Ratio of the leading coefficient 2 by 6 is 1 by 3. Limit n tends to infinity. Limit n tends to infinity. 1 cube plus 2 cube plus 3 cube etc. n cube divided by n power 4. Numerator is summation of n cube. Summation of n cube is n square into n plus 1 the whole square divided by 4 divided by n power 4. Both degree of numerator denominator is same. So ratio of the leading coefficient will get the answer as 1 by 4. Very simple results are given. Based on the memory we can answer these kind of questions if it is asked in the exams. Okay. And similar kind of results I'll write in terms of the greatest integer function which is asked in JEE exams. Limit n tends to infinity, limit n tends to infinity, greatest integer value of r plus greatest integer value of 2r plus greatest integer value of 3r, like this it goes on. Otherwise I'll write in the next page, that's better. Limit n tends to infinity, limit n tends to infinity, greatest integer value of r plus greatest integer value of 2r plus greatest integer value of 3r, like this it goes on. Greatest integer value of nr, whole thing is divided by n square. Answer is r by 2. R by 2. This is comparable to the previous one I gave you. This is comparable to this. Something like this. Okay. But here it is greatest integer function. Whatever square bracket is given here, everywhere it denotes the greatest integer function. Similarly, I can write limit n tends to infinity. Limit n tends to infinity of greatest value of 1 square r plus greatest integer value of 2 square r plus greatest integer value of 3 square r, like this it goes on. Greatest integer value of n square r divided by n cube is equal to r by 3 is answer. There we got 1 by 3 here, correct? Here it is, answer is r by 3. Both are comparable. Okay. Already in JEE exam these kind of questions are asked. So we can answer based on the memory because it's very standard, found in many of the books. Correct? So limit n tends to infinity, limit n tends to infinity, greatest integer value of 1 cube into r plus greatest integer value of 2 cube r, greatest integer value of 3 cube r, greatest integer value of n cube r divided by n power 4. Divided by n power 4. Answer is going to be equal to r by 4. This is comparable to this. Okay. Hope it's clear how to remember. Answer is here in this case 1 by 2, 1 by 3, 1 by 4 is answer. Here the answer is r by 2, r by 3, r by 4. Okay. And denominator n square, n cube, n power 4. Here also denominator is n square, n cube, n power 4. And numerator we got the greatest integer function here. Okay. And r is some variable here. Okay. Where in each of these results are given here, square bracket denotes the greatest integer function. Square bracket denotes the greatest integer function. Greatest integer function denotes the greatest integer function. Hope it's clear. Move on to the next one. Limits involving the exponential and logarithmic functions. Okay, exponential and logarithmic limits I'll give you. Exponential and logarithmic limits. Exponential and logarithmic limits. The first one we have limit n tends to infinity. 1 plus 1 by n to the power n is equal to e. Limit n tends to infinity. 1 plus 1 by n to the power n is equal to e. E is a number which lies between 2 and 3. E is an irrational number whose value is approximately 2.71828. It's an irrational number. It's a friend of pi. Limit x tends to 0. E power x minus 1 by x is 1. E power x minus 1 by x is equal to 1. Limit x tends to 0. A power x minus 1 by x. Limit x tends to 0. A power x minus 1 by x is log a base e. Log a base e. Limit n tends to infinity is over. No? Limit x tends to 0 I'll give. Limit x tends to 0. 1 plus x to the power 1 by x is also e. 1 plus x whole to the power 1 by x is e. limit x tends to 0, log of 1 plus x by x is 1. Limit x tends to 0, log of 1 plus x divided by x is equal to 1. Log of 1 plus something by something is 1. Of course, the base is e here. If I don't write any base for log, it's understood that the base for the logarithm is e. E is a standard base for log. Okay, limit x tends to 0, e power x minus 1 by x1. Here the power and the denominator should be same. Here log of 1 plus something by something, x same. Limit x tends to 0, 1 plus x power 1 by x is e. Limit x tends to 0, a power x minus 1 by x is log a base e. Here the power and the denominator should be same. Okay, so all these things connected to exponential and logarithmic limits. Exponential and logarithmic functions also I can call. Limits of exponential and logarithmic functions. Next we got one result here. Result connected to trigonometric exponential. See, wherever I get 1, I can merge all those things. Here you see that limit x tends to 0, e power x minus 1 by x is 1. Limit x tends to 0, log 1 plus x by x is 1. These two we got 1. And also in trigonometry we had limit x tends to 0, sin x by x 1. Correct? We had earlier limit x tends to 0, sin x by x is 1. Limit x tends to 0, tan x by x is 1. Correct? X tends to 0, sin x by x is 1. Limit x tends to 0, tan x by x is 1. Sin inverse x by x is 1. Limit x tends to 0. Where there is 1, I'll combine all those things and write one result where you can answer directly. One such question was asked in JEE Main exam in 2025. That's why I'm giving this. Limit x tends to 0, sin inverse x by x1. Limit x tends to 0, tan inverse x by x is equal to 1. Correct? Like this. Where we got 1, this and these 4. These 4 you consider. Okay? And these 2 you consider. Combining all these things, I can give one result here. And the coefficient of x matters here. Okay? The result what I'm going to give here is limit x tends to 0. Suppose I give sine to the power, say sine to the power lambda 1 of ax, sine to the power lambda 1 of ax, or sine x to the power lambda 1, I'll write sine x to the power lambda 1, sine x to the power lambda 1 into, say, tan bx to the power lambda 2. Okay, I can consider the product as well as quotient. I can consider one more here, e power cx minus 1 to the power lambda 3. Okay, and divided by log of 1 plus dx, to the power lambda 4. Okay, and next I'll consider sin inverse of ex, to the power lambda 5 into tan inverse of fx, to the power lambda 6. Answer for this is going to be equal to, a power lambda 1, b power lambda 2, c power lambda 3 divided by d power lambda power 4, e power lambda power 5, f power lambda power 6, provided lambda 1 plus lambda 2 plus lambda 3, provided sum of the powers in the numerator should be same as the sum of the powers in the denominator. Lambda 1 plus lambda 2 plus lambda 3 should be equal to lambda 4 plus lambda 5 plus lambda 6. Of course, lambda i's are natural numbers you can take, or else any number. The sum should be same. That is important. It need not be natural numbers. It can be even the rational numbers also. Okay. I'll take for all lambda I belongs to Q, a set of rational numbers. I'll take except 0. Don't take 0. All rational numbers except 0. I belongs to this 1, 2, 3, 4, 5, 6. I am given one format here. It need not be present all these things. It can be interchanged also. I can interchange. Whatever present in denominator can be taken to numerator also. Or some of them in the denominator, some of them numerator. Can interchange. I hope you understand the pattern here. So sine function, tan function, sine inverse, tan inverse, e power x minus 1 and log of 1 plus x. Such function should be present. In that case, the powers, no, if you take the sum of the powers in the numerator, that should be same as sum of the powers in the denominator, and answer is going to be, if the limit extends to 0 is given, in that case I am telling you, answer is a power lambda 1 into b power lambda 2 into c power lambda 3 divided by d power lambda 4 e power lambda 5 into f power lambda 6. Hope you understand. It need not be present all the 6. They can give only 2 or 3 or 4 sometimes like that. So hope you understand the pattern. Same way I can write even for sine and tan function. Only if it is sine and tan function also I can write. Limit extends to 0. Suppose again like this. Sine ax to the power lambda 1. Okay. And simply I can give bx here. Bx to the power lambda 2 divided by tan cx to the power lambda 3 tan cx to the power lambda 3 into dx to the power lambda 4. This is going to be equal to a power lambda 1 into b power lambda 2 divided by c power lambda 3 into d power lambda 4. Okay, so a, b, c, d are real numbers, not all 0. Okay, understood. Lambda I belongs to q minus 0. All rational numbers except 0 I can take, provided lambda 1 plus lambda 2 should be equal to lambda 3 plus lambda 4. Lambda 1 plus lambda 2. Sum of the powers in the numerator should be same as sum of the powers in the denominator. Hope it's clear. Okay, so look at the pattern and write. Even I can give like this. Limit extends to 0. I can write like this also. Limit extends to 0. Say e power ax minus 1 to the power lambda 1 into log of 1 plus bx whole to the power lambda 2 divided by sine inverse of cx to the power lambda 3. This is going to be equal to what? A power lambda 1 into b power lambda 2 divided by c power lambda 3, where lambda 1 plus lambda 2 should be equal to lambda 3. Numerator, there is product of two, correct? Two functions. Denominator contains only one function. So sum of the powers of numerator should be same as the power of denominator. Each lambda I belongs to q minus 0 I'll take. Each lambda I belongs to set of rational numbers except 0. Okay, and a, b, c are real numbers. None of them should be 0. Don't take 0. It becomes meaningless in that case. Okay, a, b, c not equal to 0. And a, b, c are non-zero numbers. A, b, c not equal to 0. You can take even negative also, no problem. Better we take a, b, c positive only. A, b, c are positive here also. Where a, b, c, d are positive. Coefficients better will take positive, so that if you take negative number, the negative number, you can take negative also, but still I can insist the condition that a, b, c, d positive or a, b, c, d not equal to 0, enough, that is enough. Okay, so quite useful result. Even in JEE exam this question is asked, this type of result is already asked in the exam. So directly we can write the answer straightforward. Okay, so this is about important result I given here on mixture of all trigonometric, inverse trigonometric, logarithmic and exponential function. Next I'm going to give you the series expansion. Infinite series expansion is quite useful because many times questions are asked to find the unknowns using the L'Hopital's rule, one of the familiar result we have. Infinite series expansion. There we have Maclaurin series expansion, and also I'll give the series expansion for others. Infinite series expansions. Infinite series expansions. The Maclaurin series expansion, the first one I'm going to give you, that is f of x, the more general case. The Maclaurin series expansion is given by this. F of x is equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus x cube divided by 3 factorial into f triple dash of 0 Like this, it goes on. Infinite series expansion. This is called as Maclaurin series expansion. Maclaurin's series expansion. Maclaurin's series expansion. Maclaurin's series expansion. Based on that, we have the infinite series expansion like this. E power x. E power x is given by 1 plus x squared by 2 factorial plus x cube divided by 3 factorial. Like this it goes on. X cube divided by 3 factorial. X power 4 divided by 4 factorial, etc. up to infinity. Infinite series expansion. E power minus x. It's alternate plus minus. Same as above, alternate plus minus. 1 minus x plus x square divided by 2 factorial minus x cube divided by 3 factorial plus x power 4 divided by 4 factorial minus etc. up to infinity. Infinite series expansion for e power minus x. Also you can write for log 1 plus x. Log 1 plus x is given by x minus x square divided by 2 plus x cube divided by 3 minus x power 4 divided by 4 etc. up to infinity. Log 1 plus x. No factorial here. Don't get confused. There is no factorial in series expansion for log 1 plus x and log 1 minus x. Here log 1 minus x is minus of x plus x square by 2 plus x cube by 3 plus x power 4 by 4 etc. up to infinity. Minus of, okay, log of 1 minus x. Next we have series expansion for a power x, right? A power x is 1 plus a power x is nothing but e power x log a. A power x is nothing but e power x log a, correct? E power x log a, because x log a is log a power x. X log is log of a power x. E power log a power x is a power x. So wherever there is x, you write x log a from this. Okay, series expansion for this. You remember this so that we can write the series expansion for e power x. From e power x, I can write a power x, because e power x is a power x is e power x log a. X log a is log a power x, correct? This is same as e power log a power x. E power log a power x is same as a power x. So replace x by, replace in this expansion of e power x, replace x by log a power x or x log a, x log a. So 1 plus x log a, 1 plus x log a plus x square by 2 factorial into log a the whole square plus x cube by 3 factorial into log a the whole cube. Like this it goes on. Expansion for a power x plus x power 4 divided by 4 factorial into log a to the power 4. Like this it goes on, etc. up to infinity. Okay, infinite series expansion for all these things. Next we'll go to trigonometry functions, sine, cos, tan, all those things. You can write the series expansion for sine x. Sine x is given by x minus x cube divided by 3 factorial, x minus x cube divided by 3 factorial plus x power 5 divided by 5 factorial minus x power 7 divided by 7 factorial, etc. up to infinity. Next we got series expansion for cos x. Cos x is equal to 1 minus x square by 2 factorial plus x power 4 divided by 4 factorial minus x power 6 by 6 factorial, etc. up to infinity. Tan x is equal to, tan x is equal to x plus x cube divided by 3 plus 2 by 15 x power 5, etc. up to infinity. Next I'll write for sine inverse x. Sine inverse x is given by x plus 1 square into x cube divided by 3 factorial plus 1 square into 3 square into x power 5 divided by 5 factorial plus 1 square into 3 square into 5 square into x power 7 divided by 7 factorial, etc. up to infinity. Next I write the series expansion for tan inverse x. Tan inverse x is given by x minus x cube divided by 3 plus x power 5 divided by 5 minus x power 7 divided by 7, etc. up to infinity. Series expansions. So sin inverse x and tan inverse x and the trigonometric function sin cos tan. Please make a note of infinite series expansion is very much useful for competitive exams like JEE. About Maclaurin series and infinite series expansions for various functions, and these functions like exponential, log and trigonometry, they're called as transcendental functions. Okay, the non-polynomial functions. Non-polynomial functions are also called as transcendental functions. Okay, in integration by parts we study isolate their inverse trigonometry function, logarithmic function, trigonometric and exponential. Other than algebraic, remaining 4 are called as non-algebraic functions. They are called as transcendental functions. Okay, so please make a note of this. And there is no factorial notation in tan inverse x of series expansion. But the next one introduce about the L'Hopital's rule, and also 1 to the power infinity is there. One more very important, L'Hopital's rule, LH rule I can call. It's applicable whenever it takes 0 by 0 or infinity by infinity form. L'Hopital's rule. 0 by 0 applicable whenever the given limit of the given function takes 0 by 0 or infinity by infinity form. Suppose limit extends to a f of x by g of x is given. Okay, if it takes 0 by 0 or infinity by infinity, in that case if it takes 0 by 0 or infinity by infinity form, the L'Hopital's rule says you differentiate both numerator and denominator separately. Okay, takes 0 by 0 form or infinity by infinity form. In that case, differentiate both numerator and denominator separately. Differentiate both numerator and denominator separately. Both numerator and denominator separately. So differentiate both numerator and denominator separately. Continue this process of differentiating numerator and denominator separately until that indeterminate form is removed to get a finite answer. Okay, that is, we get limit x tends to a f dash of x by g dash of x, f dash of x divided by g dash of x. Differentiate numerator and denominator separately. Suppose then you can apply the limit. This becomes f dash of a divided by g dash of a. If this is a finite answer, is a finite number, then you can stop. Is a finite number, then the process terminates, stops. If it is still in indeterminate form, 0 by 0 or infinity by infinity, then continue this process. If this takes 0 by 0 or infinity by infinity form, if this takes 0 by 0 or infinity by infinity form, then differentiate both numerator and denominator separately. Differentiate both numerator and denominator separately. Differentiate both numerator and denominator separately. That is, limit x tends to a f double dash of x divided by g double dash of x. Limit x tends to a f double dash of x by g double dash of x. That is, limit x tends to a f double dash of a divided by g double dash of a. Continue this process of differentiating numerator and denominator separately until that 0 by 0 form or indeterminate form is removed. Infinity by infinity form is removed. Okay. Continue this process until that indeterminate form is removed. Okay. Is a finite number. Even this is not a finite number, then continue this process by differentiating numerator and denominator separately until you get a finite number or indeterminate form is removed. Okay, you can write the sentence. I can write in the next page. Continue this process. Continue this process. Continue this process until the indeterminate form is removed. Until the indeterminate form is removed. Until the indeterminate form is removed. Next, I go to 1 to the power infinity form. 1 to the power infinity form. Suppose limit x tends to a f of x to the power g of x. Limit x tends to a f of x to the power g of x is given like this. The exclusively required for JEE exams. It's very important concept. Okay. If you want to apply, you want to evaluate this limit. Suppose it takes 1 to the power infinity form. As x is approaching a, f of x is approaching 1 and g of x is approaching infinity. In this case, we can write as x is approaching 1, as x is approaching a, f of x is approaching 1 and g of x is approaching infinity. This is e power limit x tends to a, g of x into f of x minus 1. E power limit x tends to a, g of x into f of x minus 1. Very much useful. Okay. F of x for g of x. Limit x tends to a, f of x for g of x. As x is approaching a, the base is approaching 1 and the power is approaching infinity. In that case, the formula is e power limit x tends to a, g of x into f of x minus 1. Very much useful for JEE exam. Very, very important. Next, I go to sandwich theorem. Sandwich theorem. Questions are asked based on sandwich theorem. Before telling about the sandwich theorem, also I can tell you that as x is approaching a, if a function three functions are given to you, f of x, g of x and h of x. Okay. Note that if three functions are given, f, g and h, f, g and h are such that f, g and h are such that f of x less than or equal to g of x less than or equal to h of x. F of x less than or equal to g of x less than or equal to h of x. Okay. Then I can write this implies limit x tends to a f of x less than or equal to limit x tends to a g of x less than or equal to limit x tends to a g of x less than or equal to limit x tends to a h of x. Even if you apply the limit, no, the inequality remains the same. For three functions f, g and h, three functions are in this form. F of x is less than or equal to g of x less than or equal to h of x. If you apply limit for all the three, limit x tends to a for each of this, still the inequality remains the same. This is a fundamental thing I given information before learning sandwich theorem. Now the sandwich theorem says that the three functions f, g and h are such that f of x less than or equal to g of x less than or equal to h of x. Limit of f of x and limit of h of x is approaching to some number L. Then the limit of the middle one, g of x, is sandwiched between f of x and h of x. The middle one is also approaching L. Okay, according to sandwich theorem, the three functions f, g and h the three functions are given to you, f, g and h. The three functions f of x, g of x and h of x are such that f of x less than or equal to g of x less than or equal to h of x. F of x less than or equal to g of x less than or equal to h of x. Okay, then as if limit extends to a f of x, limit extends to a f of x is equal to limit extends to a h of x, limit extends to a f of x and limit extends to h of x. Limit of this and limit of this as x approaches a becomes L. Then limit extends to a g of x is also L. Limit extends to a g of x is also equal to L. Limit of f and limit of h both are L. Then the limit of g is also L. Okay, this is sandwich theorem. You can draw the graph also. Three functions f, g and h are such that it satisfies this f of x less than or equal to g of x less than or equal to h of x. Like this, x is approaching a, f of x is approaching L. This is f, g and h. The first one is f, the second one is g and the third one is h. F of x less than or equal to g of x less than or equal to h of x. As x is approaching a, limit of f is L, limit of h is L and limit of g is also going to be L, because g of x is sandwiched between f of x and h of x. Sandwich theorem, hence the name given. Or is also called as squeeze play theorem. It's also given the name squeeze play theorem because it is squeeze play theorem, and then the name is given as squeeze play theorem. Okay, 1 to the power infinity, sandwich theorem, and infinite series expansion, L'Hopital's rule. Next we got Newton-Leibniz formula, one of the most important. Even in integration also require, even in limits also we need this Newton-Leibniz formula. Newton-Leibniz rule. Newton-Leibniz rule. Whenever you want to differentiate a definite integral, normally we apply Newton-Leibniz formula. Many times in competitive exams like JEE exams, what they do is they ask you to they ask you to evaluate a limit where it involves integration. Limit of a definite integral is given to you. In that case, it takes normally 0 by 0 form. So you need to differentiate numerator and denominator separately. To differentiate a definite integral, we use Newton-Leibniz formula. Okay, Newton-Leibniz rule also I can call d by dx, differentiating a definite integral. U of x is the lower limit and v of x is the upper limit. Okay, the function is f of t dt. F of t is the function, where f is a continuous function in the closed interval ab. U of x and v of x are differentiable functions whose values lies in the interval ab, where f is a continuous function in the closed interval ab. F is continuous in the closed interval ab, and u of x and v of x are differentiable functions. U of x and v of x are differentiable functions whose values lies in the interval ab. U of x and v of x are differentiable functions. Differentiable functions whose values lies in the interval ab. Differentiating a definite integral d by dx. Lower limit is function of x, upper limit is function of x. You are differentiating with respect to x, and the function is of t, f of t dt. The variable for integration is a t. So in that case, what happens is integration and d by dx are going to cancel out, nullify. Okay, evaluate the function in upper limit, f of v of x into v dash of x. Substitute the upper limit into differentiate the upper limit, minus substitute the lower limit into differentiate the lower limit, f of u of x into u dash of x. Substitute the upper limit in place of t, put the upper limit into differentiate the upper limit, minus In place of t, put the lower limit into derivative of lower limit. This is called as Newton-Leibniz formula. Quite useful to differentiate a definite integral. Even limits, many times questions are asked based on this. So I have given it here. Okay. So we discussed about the Newton-Leibniz formula, about infinite series expansion, Maclaurin series expansion, and also L'Hopital's rule, Sandwich theorem, 1 to the power infinity. Such an important formula it is. Frequently questions are asked based on that, 1 to the power infinity. Okay, and also about the infinite series expansions are given to you. Also limited infinity is given, limit of exponential and logarithmic functions, trigonometric functions, and one beautiful result which involves trigonometric, inverse trigonometric, exponential and log. Such a beautiful result is given here. Okay. And also about the greatest integer function I told you about the limit at infinity, limit x tends to 0. This is another important result. Okay. And two more results I can tell you here is on based on this 1 to the power infinity. It is actually based on 1 to the power infinity only. Limit x tends to infinity. Suppose it is given like this. Limit x tends to infinity. Limit x tends to infinity. X plus alpha by x plus beta to the power x plus k to the power x plus k. If it is like this, answer is e power alpha minus beta, because as x is approaching infinity, the base is approaching 1 and the power is approaching infinity. Because of that we have this. It takes 1 to the power infinity form. Another one I can go into gives limit x tends to 0, limit x tends to 0, a power x plus b power x plus c power x divided by 3 whole to the power of 1 by x. In this case, answer is going to be cube root of ABC. Cube root of ABC. Okay. In general, I can give it for n numbers here. Limit x tends to 0. Limit x tends to 0. A power x plus b power x plus c power x, etc. Otherwise, I can write in terms of, okay, no problem. I'll write in terms of 4 numbers, okay. D power x divided by 4 whole to the power of 1 by x. Okay, in this case, answer is going to be 4th root of ABCD. Okay, because this also takes 1 to the power infinity form. A power 0 is 1, B power 0 is 1, C power 0 is 1, D power 0 is 1, correct? 1 plus 1 plus 1 plus 1 becomes 4. 4 by 4 is 1, 1 to the power infinity form. Another important result I am going to give you is about the application of what do you call that result I gave you. A limit n tends to infinity, a power n becomes 0 if a lies between 0 and 1. Based on that, limit already gave this result. Limit n tends to infinity, limit n tends to infinity, a power n becomes equal to 0 if a lies between 0 and 1, correct? If a number lies between 0 and 1, to the power infinity is 0. Already told this result. Based on this, we have limit n tends to infinity. Based on this, we have limit n tends to infinity, a power n plus b power n, a power n plus b power n to the power 1 by n is going to be equal to a if a is greater than b is greater than 0. Both a and b are positive and the bigger number is a. Same way I can write one more. Limit n tends to infinity. Limit n tends to infinity. A power n plus b power n plus c power n whole to the power 1 by n. Answer is going to be a if a is greater than b is greater than c is greater than 0. All a, b, c are positive and a is going to be the highest, because highest number is a, means you take a power n common. A power n if you take out, a power n power 1 then becomes a. What remains will be 1 plus b by a power n plus c by a power n. b by a is going to be less than 1. Less than 1 power infinity is 0. c by a power n becomes 0 because c by a is a number less than 1. A is greater than c means c by a is going to be less than 1. If a number lies between 0 and 1, to the power infinity is 0. Based on that, we have these results. Okay, so I completed all the formulas connected to limits. Okay, beautiful results are given also on limits of trigonometric functions, exponential function, logarithmic function, series expansion, L'Hopital's rule, 1 to the power infinity, infinite series expansion, Maclaurin series expansion, Newton-Leibniz formula, sandwich theorem, everything has been explained in short, okay, in brief I have explained, and also the formulas are given here of various things, okay. So limits has been completely dealt with formulas, okay. So indeterminate forms we had, algebra of limits, introduction to limits, okay. So and some more things I can give you here is limit extends to 0, mod x by x limit does not exist. You can remember this. Whenever it comes to left hand limit and right hand limit, remember that. When do you have to calculate left hand limit and right hand limit separately is whenever you got functions like this, square root function, modulus function, greatest integer function, okay, then step up function or a piecewise function. Functions are defined in pieces. We call it as piecewise functions, signum function. In all these cases, no, we have to find out left hand limit and right hand limit separately. In these kind of functions, need to find out left hand limit and right hand limit separately. You have to find out, okay. Square root function, modulus function, greatest integer function, or even fractional part function, fractional part of x minus greatest integer function x, that you must know, okay. In all these cases, we find out left hand limit and right hand limit separately. Piecewise functions are defined in pieces, 2 pieces or 3 pieces, like that. In that case, we have to find out left hand limit and right hand limit separately. If you want, I can give one more important thing is limit extends to 0, mod x by x does not exist. You can remember that, okay. Remember that limit extends to 0, mod x by x does not exist. Limit extends to 0, limit extends to 0, mod x divided by x does not exist, because left hand limit is minus 1 and right hand limit is plus 1. Limit extends to 0, mod x by x does not exist because left hand limit is equal to minus 1 and right hand limit is plus 1. It's better to remember this, okay. Limit extends to 0 of greatest integer function also does not exist. Limit extends to 0 of greatest integer function does not exist. Here if you calculate left hand limit extends to 0 minus, that will be minus 1, and right hand limit extends to 0 plus is going to be equal to 0. Left hand limit is minus 1 and right hand limit is 0. Limit extends to say any integer value. Limit extends to a of greatest integer function does not exist if a is an integer. Does not exist for all a belongs to z. For all a belongs to z, integer. And limit extends to a or extends to b, alright. Extends to b of greatest integer function exists if b is a non-integer. Exist for all b belongs to non-integer. How to write non-integer? From the real numbers, we remove all the integers, we get non-integers. So limit extends to b of greatest integer function exists only if b is a non-integral value, okay. In that case exists. B should be non-integer. From the real numbers, remove all the integers, what we get is non-integer values. So all these things is better to remember, okay. Some more things I'm going to give you here is limit extends to 0. Even this question is asked many times. Limit extends to 0 of square root of 1 minus cos 2x. 1 minus cos 2x is 2 sin square x, correct, divided by x, if I give like this. Here, whenever there is square root function, we need to find out left hand limit and right hand limit separately. So in that case, 1 minus cos 2x is 2 sin square x. 1 minus cos 2x is going to be 2 sin square x. 2 sin square x divided by x, which is equal to root 2 into limit extends to 0, root of sin square x I'm getting. Root of sin square x is mod of sin x. Remember that root of x square is going to be equal to mod x. Root of x square is mod x. Root of sin square x is mod of sin x. Mod of sin x divided x. In this case, you have to find out left hand limit and right hand limit. Limit of this does not exist. Here it does not exist. Limit of this does not exist because the left hand limit is going to be, left hand limit of this is going to be minus 1. Minus 1 into root 2 is minus root 2. and right hand limit is going to be mod of sin x becomes sin x by x 1, so root 2 into 1 root 2. Left hand limit is minus root 2 and right hand limit is plus root 2. So limit of that does not exist in that case. Limit of this does not exist. All these things is better to remember, okay? Even if I ask limit x tends to 0, sine of mod x by x, limit x tends to 0, sine of mod x divided by x does not exist because left hand limit is minus 1 and right hand limit is plus 1 here. Because left hand limit is minus 1 and right hand limit is plus 1. X tends to 0 of this does not exist. If I ask limit x tends to infinity of this, limit x tends to infinity of sin x by x, limit x tends to infinity of sin x by x. As x tends to infinity, sin 1 by x tends to 0. So 1 by x is approaching 0. Sin x is a finite number, so it becomes equal to 0. Because as x tends to infinity, 1 by x is approaching 0. 1 by x approaches to 0. Okay. And sin x is a finite number which lies between minus 1 and plus 1. Limit x tends to infinity, tan x by x also we can tell because 1 by infinity is 0, correct? So because of that we can write limit x tends to infinity, sin x by x is equal to 0. And one more thing I can tell you is limit x tends to infinity of log x by x. X tends to infinity is there. Okay. This was of number 7, 8th one. You must know that very important thing is about the greatest integer function. Greatest integer function is always less than or equal to x and it is greater than x minus 1. Because of that I can tell you that greatest integer value of x is always less than or equal to x and it is greater than x minus 1. Greater than x minus 1. So we can divide the entire inequation by x. So if you divide by x, x minus 1 divided by x less than greatest integer value of x divided by x less than or equal to x by x, correct? That is, we can write this as 1 minus 1 by x, separating and writing greatest integer value of x by x less than or equal to 1. Now if you take limit x tends to infinity for this, limit x tends to infinity of 1 minus 1 by x is going to be less than limit x tends to infinity of greatest integer value of x divided by x is less than or equal to limit x tends to infinity of 1, correct? And limit of 1 is 1. As x tends to infinity, 1 by x tends to 0. So 1 minus 0 becomes 1. This is 1. This is 1. So this is sandwich. Using sandwich theorem, we can tell that limit x tends to infinity of greatest integer value of x by x is 1. By using sandwich theorem, we can tell. By sandwich theorem. Sandwich theorem, we can conclude that limit x tends to infinity of greatest integer value of x divided by x is equal to 1. Please make a note of this. So with this, I think I completed everything of limits. Various things of concept of limit. This is very important for JEE exams. Many more videos will be uploaded in the coming days. I'll be completing this series of revising all the formulas and concept of all the topics of both first PU and second PU. Please forward to your friends. Subscribe to my channel Abhiram's Maths Marathon. With this, I conclude. Thank you.